Okay guys, I know there was a few questions you had about scientific notation and significant figures. So I'm going to go through just a few of the problems on this worksheet, and that'll kind of set you up to get it finished. So let's look at number one. Number 1, 2, 3, and 4, you've got to write the number in scientific notation. And scientific notation has one digit and then the decimal point, and then possibly another a number of other numbers, and then it's got a multiplier. So the number 538.35, we're going to write that as 5.3835, but then we're going to put a multiplier next to it, 10 to the power of 2. And those two numbers are equal in value. They're just written in different ways. We started with standard notation, and we ended up in scientific notation. And so if you move the decimal point to the left of a number to get it into scientific notation, you're going to balance that out by multiplying it by 10 to the power of 2. Then if you have to convert to decimal format or standard notation, I prefer that term. Let's look at number 5. This number's in scientific notation, 8.56 times 10 to the power of 4. So we're going to multiply everything out. And when we multiply everything out, what we essentially are doing is we are moving our decimal point. Because that's 10 to the power of 4, we're going to move the decimal point 4 places to the right. And when we do that, the number changes to 85,600. Now 85,600 is equivalent to 8.56 times 10 to the 4. It's just written in standard notation, which in this case it's called decimal format. Number 8 has a multiplier that is raised to a negative power, 1.39 times 10 to the negative 6. So what we're going to do is we're going to shove some zeros in front of the 139, move our decimal point 6 places to the left this time, because it's 10 to the minus 6. And when we do that, we're going to get 0.0000139. So when you're taking a number into standard notation from scientific notation, if it's raised to the positive power, you move the decimal point to the right. If it's raised to the negative power, you're going to move the decimal point to the left. The next few questions, you have to say how many significant figures are in each of those numbers. Now, we practiced this in class, but I want to just look at number 12. Number 12, 6.022 times 10 to the 23. That number is going to become very meaningful and useful to us later on in the year. But we don't need to worry about the 10 to the 23 in terms of significant figures. We're just going to look at the 6.022, and we've got 4 significant figures there. The next few, you had to round off to the number that's, you had to round off each number as indicated. So number 15, for example, we've got a number 0.4692. We've got to round to 2 significant figures. So that gives us a 4 and a 6. So 0.46 is 2 significant figures. The next number is a 9, and that 9 is going to change the 6 to a 7. And that's why we get 0.47 as our final answer. A rule to follow, and I heard this from a student last year, is 4 and below, let it go. 5 and above, give it a shove. So since 9 is above 5, it's going to shove that 6 up. So we're going to round the 6 up. But 0.47 has now got 2 significant figures, and we've rounded the number. Number 17, it says round to 3 significant figures. So 3 significant figures would be 8, 9, 9. Now we look at the next number, and that's a 9. So that 9 is going to round the next 9 up to a 10, which would cause the 9 next to that to change to a 10. And so overall, our answer is going to be 900. But it's 900 with a decimal point. 900 with a decimal point, or 900 point, has got 3 significant figures. It looks kind of weird because there's no 0 after the decimal point, but it is acceptable to write a number like that, and it just says to us that you have 3 significant figures in it. The last few problems, you have to multiply or divide or add and subtract. Number 19, what we're going to do is we're adding, and when you're adding, you've got to look at the lowest number of decimal places to get the right precision in your answer. So if you look at those three numbers, 23.6 has only got one decimal place. So that means our answer has to have only one decimal place. So 464.25 is actually wrong. What I've written there, it's going to be 464.3, because that 5 is going to round the 2 up to a 3, and there's our one decimal place. So adding and subtracting, you look at decimal places. Number 21, you're multiplying in this case. And when you multiply, you've got to look at significant figures. So our final answer has to have the correct number of significant figures. 1.34 has got 3 significant figures. 6.3 has got 2. So our answer has to have 2. So in your calculator, if you do 1.34 times 6.3, you're going to get 8.4. And then we just put the 10 to the 15 in there. And the 8.4 was a different number, but I rounded it to 8.4 because in my final answer, I only wanted 2 significant figures. So try the rest of this, get it finished. Let me know if you've got any questions.